Chapter 2, Section A, Video, Relationships and Functions. In today's video, we're going to look at what makes a relationship, and then more exactly, what type of relationship is a function. So a relationship, very simply, is a set of any points which connect two variables. There are three ways that we will see relationships. The first one is you will see as a set of points, just a grouping of points. The second method of describing a relationship is to write an equation. And the third is to graph a graph of the relationship. So plot the values. When we talk about relationships, relations and functions can be broken up to two main things: the domain component and the range component. So when we're graphing, the domain is the horizontal axis and the range is on the vertical axis. So the domain is usually the x variable, because that's what's graphed on the horizontal axis. It's the first number in the order pair, or it's also called the input value inside the equation. The range is sometimes called the output value. It is the second number in the order pair, and it's graphed on the vertical axis. For today's video, we're just going to introduce the terminology for domain and range, and I'm going to do a few examples where I do find the domain and range, but I just want you to introduce this concept, and video B will talk in more detail of finding the domain and range. The special type of relationship that we call a function. A function is a relationship in which no two different ordered pairs have the same x-coordinate or force component. So in other words, for a mapping or order pair to be a function, the x-coordinates go to one and only one y value. So that the x-coordinates do not go to multiple y values. That makes it a function. In this section, we'll learn three tests to determine if a relationship is a function. And which test we use depends on which data we're given. So if we're given a list of ordered pairs, then the way to test and see if it's a function, you will map out the ordered pairs, and I'll show you an example of what mapping looks like. We have the domain in one circle and a range in the next circle. And you'll look and see if you have two lines leaving from a single x value. So if the same x goes to two different y values, then this fails the test and the relationship is not a function. So let's do a few examples of this first test for function using the mapping process. So here's a set of points. So this is a relationship, and I'm going to figure out my domain and range. So remember, my domain, when it's in an order pair, is my first values. So 1, which is repeated twice. So here's my highlighting. My domains are 1, 1, 2, and 2. So when I list my domains, I only have to list each number once, and I'm going to always list the numbers in increasing order. So now I'm going to list my range values. So we can see here that my range values in increasing order are -6, -4, 4, and 6. Now we're going to do our mapping of this data. So in the mapping, what you do is you draw two elongated circles or ovals. In the first circle, you put your domain values, so that's a 1 and a 2. In the second circle, I put all my range values in increasing order. Now I look at each point, and I have the point 1, 4, so I draw a line from 1 to 4. So that's mapping, so 1 maps onto 4. In my next order pair, I have the number 1, -4. So 1 on the domain maps onto -4 on the range. Third order pair is 2, 6, and 2, -6. So 2 maps to 6 and 2 maps to -6. So notice on each of these, on the 1, notice we have 2 lines going out of it. So this means that this is not a function. And we have 2 lines going out from the 2. So that is not an example of not a function. It's just a relationship. On our second example, let's do this again. So I'm going to identify my domain. Remember, domain is the x values, or the values listed first, your input values. We're going to write them in increasing order, not repeating any. So I got -3, -2, 1, -1, 0, 1, 2, and our range value are our y's. So let me highlight these. 3, 5, 7, 1, 4, and 5. So let me write those in increasing order. That'll be 1, 3, 4, 5, and 7. Now we're going to do our mapping to illustrate if we have a function or not a function. So I'm going to draw my first oval. And in this oval, I put all my domain values. In my second oval, I'll put all my range values. Now I go down 1 point at a time, 0, 2. So from the 0 in the domain, I draw a line to the 3 in the range. I repeat this for every single point. -1 maps onto 1. -2 maps onto 4. And -3 maps onto 5. To determine if this is a function or not, I look at my domain circle and I look at each of these values and see if I have more than one line going out of them. So every single x value only has one line going. That means it's only going to a single y value. So that means that this is an example of a function. Okay, our second test is called the algebraic test, and we use this when we're given an equation. So if a relation is given as an equation, and the substitution of the values of x results in one and only one value of y, then the relationship is a function. So the process we're going to go through this to solve the algebraic test is we're going to rewrite our equation so that it's y equals. And if it's explicitly defined as y equals a single expression, then it is a function. So let me go through an example. We have x squared plus y equals 5. So get the y by itself by subtracting x squared to each side. I have y equals 5 minus x squared. That's a single thing that y is equal to. So this is an example of a function. Our second example, I have x equals y squared. So to solve y by itself, I take the square root of each side. So I get y is equal to plus or minus the square root of x. So that means y is equal to square root of x and y is equal to negative the square root of x. Let me change that or to negative. And y is equal. So this is not written implicitly. Y goes to two different values, the square root of x and negative square root of x. So this is an example of an equation that is not a function. Sometimes the equation can be difficult, so let me give you another example of an equation. So let's say y is equal to 3x minus 5. So this is already y equals. It's a single expression of y equals a single thing, 3x minus 5 every time. So that makes it a function. Okay, for example 4, I'm going to do equation of a circle. So we got x squared plus y squared equals 1. So we're going to get y by itself. So I'm going to subtract the x squared from each side. That gives me y squared is equal to 1 minus x squared. Taking the square root of each side, I get y is equal to plus or minus the square root of 1 minus x squared. So y is equal to positive the square root of 1 minus x squared, and y is equal to negative the square root of 1 minus x squared. So I'm getting two values for every x I put in. So this is an example of where it is not a function. Equation that is not a function. Our third test we use when we're given the graph, and this is called the vertical line test. And you use it when you're given the graph of the function. So vertical line test, what you simply do is you draw a vertical line through the graph, and you can do it at any point on the graph. And regardless of where you draw the vertical line, if it only touches the graph once, it is a function. If it touches the graph more than once, it is not a function. So let's look at example A. So regardless of where I draw these vertical lines, notice I'm only intersecting the function at exactly 1 point. So this is an example of a function. So A is a function. Now you don't have to draw all these lines, you only have to draw one. But I want to show you that it doesn't matter where you choose to draw your line, it's only going to hit it once. So regardless of where you choose to draw your vertical line, again you only have to draw one, it only intersects this graph at exactly 1 point. So that means that B is also a function. Can't see too well, so let me move this up a little bit so we can get that smart notebook off of it. So I'm going to do the same thing. Now if I drew the vertical line right through here at the x-axis only hits it once, but all the other times I choose to hit it at is at 2. So you always want to choose at most how many times it intersects it. So since a single vertical line intersects this graph more than once, that means C is not a function.